Hi, Assalamualaikum warahmatullahi wabarakatuh. Today I would like to explain to you about my part which is part A. Question A. Define the following error, the difference between the exact value, actual value and the approximated value, measured or observed value. B. Absolute error, the magnitude of the difference between the exact value and the approximated value. C. Relative error, the absolute error divided by the exact value. For the question 2, state the meaning of the following. A. X bar approximates X with the accuracy of 3 decimal places, which is referred to the formula modulus X minus X bar is equal or less than 0.5 times with the 10 the power of negative 3. Then B. X bar approximates X with the accuracy of 2 significant figures or digits, which is referred to the formula modulus X minus with the X bar divided by the X bar is equal or less than 5 times 10 the power of negative 2. Okay, then I will move on to the next question, which is A. Write first 3 terms of Taylor's polynomial expanded about x equal to 0, and for function epsilon 1 plus x, approximate f 0.45 using polynomial obtained. Write also expression for truncation error for approximation in terms of number error as mentioned in Taylor's theorem. Do not evaluate the expression. So the first task that we have to do is first we must find the first 3 terms of Taylor's polynomial. So the formulas given is function x equal to the function x naught plus derivation of x naught divided by 1 factorial times with the x minus x naught plus double derivative x naught divided by 2 factorial times x minus x naught square. So after that, we substitute the value that have been given in the instruction into this formula. So ln 1 plus x plus 1 over x plus 1 times with the x minus x naught plus 2 times negative 1 divided by x plus 1 square times with the x minus x naught square. So that since x naught is 0 and x is 0.45, so we will substitute the value in the equation. So the final answer that we get is since we have not to evaluate the expression, so the final answer will be ln 1 plus 1 over 1.45 times with the 0.45 minus 2 divided by the 1.45 square times with the 0.45 square. And then for the second task, which is we have to find truncation error for approximation, we will use this formula modulus remainder n plus 1 times with the x naught x1. So the formula function n plus 1 times with the error divided by n plus 1 factorial times with x minus x naught the power of n plus 1 modulus. So since the first the question 1 we want us to find n equal to 3, so we will substitute the value into the equation. So modulus f power of 4 times with the error times with the 0.45 divided by 4 factorial times with the 0.45 the power of 4. Okay. So since the first 3 terms in Taylor's theorem is n equal to 3, so when we'll substitute the value, n plus 1 will be 4. So we will get f4 times with the error times with the 0.45, since it is the value of x, divided with the f factorial times with the 0.45, the power of 4. For the part B, question number for part B, question number 1, which is A. Consider the equation x square minus 2 the power of negative x equal to the 0. Show algebraically that there exists two roots on the interval negative 3, 1. So first we will prove the equation if there exists of two roots in this equation. So we will substitute the value into we have a negative 3 and 1. So we will substitute the value into this equation, and then we will get for f negative 3 we will get 1, while for f1 we will get 0.5. So as we want to prove the roots, so we will use the formula fa times with the fb, and it must be less than 0. So when we substitute the value, we get the final answer is 1.5, which is greater than 0. So this is special case. So since it cannot be proved exists of two roots, so we use graphical solution, alternative approach. So first we will use fx is equal to the 0. So hx minus gx is equal to 0. So this is number 1. Number 2, so we will transfer the value of negative gs into the right. So we will get hx equal to the gs. So we will get fx is equal to the hx minus of gx. So we tabulate the data, and then we assign hx to the x square, while gx we assign to the power of negative x. So when we tabulate the data, we calculate this with using the calculator. So tabulate must be on the same graph. So when we plot the two graph on the same paper, we will get the intersection between the two graphs. So the conclusion is, since the hx is equal to the x square and gs is equal to the 2 the power of negative x, plotted on the same axis, and it can be concluded that there is one intersection point at s equal to the r. Therefore, it can be concluded there exists root r equal to the negative 2. So it is proven that at the end the equation is exists of two roots. So next we'll move on to the part B, which is use bisection method with 3 iterations to find a solution for the equation on the interval 0.751. Hence the accuracy in terms of number of decimal places for solution obtained. So we will have here the two value, which is 0.75 and b1, b equal to 1. So we substitute into the previous equation in the A solution. So the equation is x square minus with the 2 the power of negative x. So when we substitute the value into the equation, we will get for f 0.75 we will get negative 0.0321. For f1 we will get 0.5. Okay, since we want to prove that there exists of two roots, there exists 2 or 1 roots, there is like to prove the equation. So we will use this formula, f a times with the fb is equal to the negative 0.0321 times with the 0.5, we will get negative 0.01605, which is which is less than 0. So it is proof that this equation has root. So for this bisection method, we will have to find the c. To find the c, we will do this. So c is equal to the a plus b divided by 2, which is 0.75 plus 1 divide by 2, we will get 0.8750. So after that, we will substitute the value into this equation, FA times with the FC, and then we will get negative 0.071, which is less than 0. Second is we use FB times with the FC, and then we will get 0.1102 is greater than 0. So since F negative 0.0321 times with the F 0.2204 is less than 0, then the root will be at negative 0.0321, 0.2204. So since the question want us to find 3 iteration, so we will do the tabulation. So repeat until 3 iteration only. So I iteration 0, 1, 2, and then A1, B1, X1, FS1. So tabulate the data. Then at the end, we have to find the second test, which is states the accuracy in terms of number of decimal places for solution obtained. So we will use this formula, modulus x minus x bar is equal to the 0.7813 minus 0.8125 modulus, and then we will get 0.0321, which is when we move the point, it will get 0.312 times 10 the power of negative 1, and then it says that it is less than 0.5 times with the 10 of power negative 1. So this is how to do bisection method.
2.8 and 2.9. For A, it determine the minimum number of iterations required if you were to obtain an estimate of solution to the equation with 3 decimal places accuracy using bisection method. We know that 3 decimal places accuracy is error equal to 0.5 10 to the power of negative 3. From the interval, we know that A is equal to 2.8, B equal to 2.9. By using this formula, we can get the value of n. We substitute the value of A and B into this formula, and the value of error, the power. Then we until this step, the power of n is more than and equal to 200. We use log, so it will be like this: n log 2 more than and equal to log 200. N is more than and equal to log 200 divided by log 2. We get n is more than and equal to 7.6439. So we round off, we get this number, n equal to 8. The conclusion is, at least 8 iterations are needed to obtain 3 decimal places accuracy. For B, use Newton's Raphson method to obtain an estimate of solution with the same accuracy as in A. So accuracy is 3 decimal places. Error must be compared with less than or equal to 0.5 10 power of negative 3. The function is x power of 3 plus x minus 25. The first derivative of the function is 3x squared plus 1. We can obtain the number of x like this: xn plus 1 equal to xn minus fxn divided by f prime xn. We can obtain the midpoint, which is x naught, by adding a and b and divide by 2. We get this 2.85 for the midpoint. We use Newton Raphson method table like this: n, xn, fxn, f prime xn. So we must start by 0, 0, x naught 2.85. This value of xn, we substitute into these two functions, and we get this value and this value. How to get x1? we can get x1 by this formula. x1 equal to x naught minus fx naught divided by f prime x naught. We get this value. Then we check whether the error is more or less than and equal to 0.5 10 power f negative 3. By using this formula, x modulus of x minus x bar, which is x1 minus x naught, we get this value, 39.4 10 to the power of negative 3. We know that this value is more than 0.5 to 10 power of negative 3. So we must perform another one. We know that the value of x1 is this, 2.8106. We substitute value of xn into these two functions and we get this value and this value. Then how to get x2? x2 by using this formula, x1 minus fx1 divided by f prime x1. We get this value, 2.8101. Then we check whether the error is less than or more than and equal to 0.5 10 to the power of negative 3. By using the same formula, which is x2 minus x1, we get this 0.5 10 power of negative 3 is less than and equal to 0.5 to 10 power of negative 3. We know that if we get the same value or less than, we stop the iteration. Then value of x2 being substituted in these two functions again and we get these two values. For C, perform 3 new iterations to obtain an estimate of solution using second method. State the accuracy of the estimate in significant figures. We know that significant figures we use relative error defined by this symbol. And relative error must be less than 5 to 10 power of negative t. Function given are like this. From the interval, we know that a is equal to x naught equal to 2.8, b equal to x1 equal to 2.9. By using sequence table, we do like this, n, xn, fxn. This is the value of x naught, which is from a, and this is the value of x1, which is from b. Then we substitute this value x1 into the function, we get this value. We substitute value of x1 into this function, we get this value. Then how to get x2? By using this formula, fx1 x naught minus fx naught times x1 divided by fx1 minus fx naught. So we substitute according to the formula and we get this, the value of x2. We put the value of x2 and we substitute x2 into this function, we get this formula. How to calculate and to obtain this formula is by times the number using this arrow. Like for example, x2 2.289 times by this number and minus by 2.9 times by this number, then divided 2.289 minus this number. So we get this. Then we check for relative errors. Relative error must be less than 5 to 10 power of negative t. Relative error formula is like this, x modulus of x minus x bar divided by x, which is x2 minus x1 divided by x2. Substitute the value from the table into this formula and we get this, 32.1019 10 to the power of negative 3. We compare with the relative error. We know that this value is bigger than 5 to the power of 10 negative 3. So we must perform new iteration. By perform new iteration, we must find the new value for x3. By using the same formula, we substitute and we get this value. Then we check again. Relative error must be less than 5 to 10 power of negative t. By using the same formula, we substitute the value into this formula. Then we get this 0.1068 10 to power of negative 3 is less than 5 10 power of negative 3. So we know that this value is less than this. So we stop the iteration until x3 only. Then the conclusion is the estimated root x3 equal to 2.8101 is accurate to 3 significant figures. For part B, question 3, we are given table. Table are like this. There are 4 data in the table. So data equal to 4, n plus 1 equal to 4, n equal to 3. And it is 4k, which is 0, 1, 2 and 3. Question A asks us to obtain the Lagrange interpolating polynomial. First, we have to know Lagrange formula. Lagrange formula is like this. F naught times L naught plus F1 times L1 plus F2 times L2 plus F3 times L3. The second step is we have to calculate LKX. The formula are like this. For k equal to 0, it is L naught. The formula are like this. X minus x1 times x minus x2 times x minus x3. The upper side must not be included with x naught. The below, we have to take x naught minus by x1 times x naught minus by x2 times x naught minus by x3. From the formula, we can see that this side are the same for upper and lower. x2, x2, x3, x3. So we substitute the value into this formula. We got this function. For L1, we apply the same concept, which is x minus x naught times x minus x2 times x minus x3. The upper side should not be included with x1. That's why we use x. Below, we can use x1, but at this side, upper and lower are the same. x2, x2, x3, x3. We substitute the value into the formula and we got this function. For k equal to 2, it is L2. The upper side must not be included by x2, so it will be like this. The lower part must be included with x2, so it will be like this. We substitute the value and we got this function. It is the same with k3, which is L3. So x minus x naught times by x minus x1 times by x minus x2. You can see that we use x only because it cannot be included with x3. But for the below part, we can include x3. But at the back, we use the same as the upper part. X naught here, x1 here, x2, and x2. We substitute the value into this formula and we got this function. Third step, we obtain Lagrange interpolating polynomial by using this formula. So f naught is from the graph, from the table. So it will be like this. If we substitute, this is f naught L naught, f1 L1, f2 L2, and f3 L3. After we simplify, we got this function. Then for B, we must approximate the value of f2 using the interpolating polynomial that we have obtained in A. We can know that the value of x is equal to 2. So we substitute x equal to 2 into this function and we get this value. For C, calculate the error bound given by fx equal to negative x power of 4 plus x power of 3 minus x square minus x. We know that the table is the not equispace data type. So from table we can also know that the number of data is equal to 4. So we must differentiate 4 times. Function given are like this. So the first derivative is negative 4x cubed plus 3x squared minus 2x minus 1. The same step goes for second derivative, third derivative and fourth derivative. The highest derivative is f4x, which is negative 24. So we know that we can take x value from b, which is equal to 2. We substitute into the formula and then we calculate. The final answer is fx minus px modulus is less than and equal to 6. Thank you.